Okay, this is another. We have another question here under physics or in physics. So this question really falls under specific latent heat. Specific latent heat. So let's see how things on or issues on specific latent heat are being, resolved or solved. Let's check the question. The question says, when heat is supplied at the constant rate of 32,000 joule per minute, it takes 5.0 minutes to melt 0.5 kilogram of ice at 0 degrees Celsius to water at the same temperature. Calculate a value for the specific latent heat of ice. Like I said before, that in physics, when you have issues like this or any issue, the first thing you need to do to make your work simple and clear, and even to even gain some marks or more marks rather, is for you to be able to interpret your question. So let's interpret the question by writing here solution. Okay, let's check the question. The question says, when heat is supplied at the constant rate of 32,000 joule per minute. So rate in this case, rate in this case is equal to 32,000 joule per minute. And by the way, anytime you hear of, anytime you come across the word rate, it has to do with per time. Okay, per time. So this is rate. Okay. The next thing is, it takes 5 minutes to melt. 5 minutes. So time is 5. Time is 5. 5.0 minutes. From here, what you need to do from here is for you to, what you need to do from here, is for you to, get your quantity of heat. Is for you to get your quantity of heat. So for you to be able to get your quantity of heat, which is Q, is for you to equate quantity of heat. And by the way, it is rate, it is given by rate times time. So what is your rate? 32,000 joule per minute times time, which is 0. Which is 5.0. Okay, so if you make use of your calculator, you will discover that the answer is going to be 160,000 joule. The quantity of heat is measured in joule. This is your quantity of heat. This is not what you're asked to do. So I'm just interpreting the question. So let's go on again to the question. To melt 0.5 kilogram. Kilogram is mass. So that is 0.5 kilogram. Let's go back to the question again. The question now says, of ice, to melt 0.5 kilogram of ice at 0 degrees Celsius to water at the same temperature. Calculate a value for the specific latent heat of ice. Calculate the value for the specific latent. The specific latent heat is symbolized with a letter L. So it is equal to nothing. That's what we are looking for. So I like saying from the formula. So which formula really fits this particular issue on ground? You discover it is latent heat equal to the quantity of heat all over the mass. What is your quantity of heat? It is 160,000 joule. Okay, divided by the mass is 0.5 kilogram. And if you make use of your calculator very well, you will discover that the answer you are going to have is going to be 320,000 joule. 320,000 joule per kilogram, because the specific latent heat is calculated in joule per kilogram. So See, the question is very simple. The way I handle it is cheap and simple. Okay, let's view the question very well again. Let's view the question very well again. See, you can go through the question yourself. Take like 30 seconds to look at the question yourself. Go through it. Go through it. Okay. Now come back to the answer. Then go through the answer very well. Go through it. See, the work is simple. Your rates, you have been given the rate, you have been given the time. So what you need to do with the time, once you see rate and time, you have to get your quantity of heat, which is you multiply rate by the time. You have your answer to be this. Okay, you check the question again. You see mass was given, and you are asked to find a specific latent heat. Okay, of the ice. So from the formula, this is the formula best fit for this. In case you have a question like this next time, you substitute the values for the quantities, and you have your answer. That's the answer. So this issue is solved by physician the hardest Gore. Check it very well. You can comment, okay, share it, okay, subscribe to my YouTube channel. Okay, thank you so much for watching. I really appreciate your time.